Yo, Chuck.
Hey, what the chuck is up, YouTube? In this video, I'm going to go over Leetcode 169 majority element. So you can see here we've got an array of numbers and we're tasked with finding the most frequent or the majority element. Now, a big tell they give you in this problem is they say that the element will appear more than n divided by 2 times. Whenever you see n, that's always referring to the array length. So in this array, we would have an array length of 3. This array would be a length of 7. So we're going to divide that length by 2 and floor it. So what that's going to look like, if I have an array size of 7, I'm just going to do 7 divided by 2 equals 3.5. I'm going to floor that value, so now I have 3. And that's my halfway point, so that's my n divided by 2. But it's saying that the most frequent element, or the majority element, is going to appear greater than n divided by 2 times. So we can really just say that would be 4 in the instance of this array of numbers. So the trick about that is now I don't have to keep track of a majority number like I traditionally would in a similar problem, because I have this shortcut of like, hey, I know if my frequency of a certain number exceeds this value, I'm good to go and I can just return that value instantly, and that will save a bunch of time. So that is the problem statement. I'm going to show you 3 different solutions how to get it done. All right, let's jump into the code. All right, so for the first solution, you can see I've just copy and pasted the problem, and then I passed in some numbers from that first test case on Leetcode. So let's return those numbers to make sure our function is firing when we console log it right here. So if I run this code, you can see it's returning the array of numbers as expected. So how am I going to solve this problem? So the first way I'm going to solve this problem is by using something called a frequency counter. This is probably the knee-jerk reaction of 95% of developers when they come across a problem like this where it says, hey, we need to know the most commonly occurring element or the majority element. Their knee-jerk reaction is, oh, let me make a frequency counter. So how does that work? So first thing I'm going to do is make a object. I'll call it map. And then now I'm just going to loop over our array of numbers and store a key of the number, and then start adding up how many occurrences it has. So I'll say, oh, the key is 2. I'm going to add 1 to the occurrence. Oh, the key is 2 again. I'm going to add 2 to the occurrence. Oh, I have a new key of 1. I'm going to set 1 to the occurrence. I have another key of 1. Now it's at 2. I have another key at 1. Now it's at 3, and so on. So you're just keeping track of the frequency of all the numbers in this map object. So I'll make a for loop. Set I equal to 0 as long as I is less than nums.length, I plus plus. And each iteration of this for loop, we need to add our key, which is going to be the number at index I. So I'll say nums at index I. We're adding that to our map element. So if I was to say true, and I returned map here, just to show you what's happening, you can see we are having our key be the current number we're on, and then we're just setting it equal to true. Now this obviously isn't what we want entirely, because every time it's overwriting the current value, like for instance on this first iteration of 2, it's setting that key equal to true, and then on the next time it hits a key of 2, it's going to set it to true again. So that's really not keeping track of the frequency of the number. So how we're going to do that is we're going to use something called a short circuit. So I'm going to say map at nums I equals map at nums I plus 1, or it equals 1. So what is that saying? That's saying I'm going to set the map at key nums I equal to the current value of map at nums I plus 1 if it exists, which means if it has a value that is already in there, then I'm going to add on to that value. If no value exists on that specific key, I'm going to return 1, or I'm going to put 1 in the value of that key. So Let's just run this iteration once, and then I want to return the map object. So if I do it right here, run this code, you can see now I've ran over this first key of 2, and then I'm incrementing it by 1. But notice there's no number 1 because I haven't encountered that key yet. So that is basically how we're going to keep track of the occurrence of each number. So right now when I return it, you can see I've counted 3 instances of 1 and 4 instances of 2. Excellent. Recall from the problem statement, I can just return n divided by 2 if a number appears with a frequency of greater than n divided by 2. That suffices as the most common element. So let's make a test case. So I'll say let test equal the floor of nums.length divided by 2. So because this nums array is 7 elements long, this should return 3.5 floored, which is 3. So if I return test, it's 3. So this is the halfway point. So this would tell us what element is half, but we need to get greater than half. So I'm just going to say plus 1. And now that's going to make this 4. So if any element occurs 4 or more times in this array, I'm just going to return that, and that is my answer. So inside of our for loop, every time we increment that map at key nums of I, I'm going to check if map at the key of nums at I equals test, just return that number, right? So I'm going to say return nums at I. So what happens here? So if I run this code, it returns 2 because it knows that 2 has reached this test value. So I can actually come in here. Whoops. I want to return nums at I. Let's also return map at nums at I, just so we can see what number or what instance, what occurrence it's returning. I would expect this to be 4 because 2 is equaling to 4 times, right? So there you have it. We reached that occurrence or frequency of 4, and then we're returning 2. So let's just go back to the way we had it. Okay, we're returning 2. This is the frequency counter method, and then now I'm going to post this into Leetcode, see what happens. And it looks like it worked. So we're in the 67th percentile for time complexity, which isn't bad, and the 54th percentile for memory. So our time complexity on this algorithm is O of n, because we are just, we're looping over that nums array, right? Every time to basically store it in this map object. And our space complexity also is O of n, which isn't great, but it's not terrible, I would say. But when you say space complexity of O of n, you're referring to the inputs every time you run this array, or this function rather. So this test variable, this is considered auxiliary space. This isn't really damaging, or it's not really like draining our memory that much. It's not very much sucking up our memory, but the map object is, because this map object is related to the inputs and nums. So right now we have 7 numbers, but let's say we had 1,000 numbers or 10,000 numbers. I'm going to have to create a map object with 1,000 numbers or 10,000 numbers keys, and then I'm going to have to count the frequency of each of those keys. That's going to take a lot of memory. So that's why we say that this algorithm is a space complexity of O of n. So in the problem statement, although this answer is definitely valid and works, they give you a challenge of, can you solve this problem in linear time in an O of 1 space? Well, we already performing linear time because our time complexity is O of n, so that's good. But our space complexity is also O of n, which isn't good. So how can we get to constant space complexity? I'm going to show you that in the next solution, so let's hop over to that one. For our O of 1 space complexity solution, I'm actually going to delete all this code except for our test case, because that also is going to be helpful in this one as well. But I can no longer create that memory-intensive map object, which requires me to store all of our inputs and just takes up a bunch of memory. So what I want to actually do here is still loop over the data. So I still want to loop over these nums right here. So I'm going to make a for loop. I'm going to set I equal to 1, and then as long as I is less than nums.length, I'm going to increment I. So the logic of me starting at index 1, that means I'm starting here, right? So I'm starting here, and then I'm going to compare adjacent elements. So I'm going to actually compare the item behind each current index. So I'm going to compare these two, then I'm going to compare these two, then I'm going to compare these two, and so on. So what I need to do is keep track of the current frequency. This would make more sense, though, if I actually sorted the array. So I'm going to do that first. I'm going to say nums.sort. I'm going to pass in these parameters of A and B, and then I'm going to use the arrow function and just return A minus B. That's going to sort my array in ascending order, so let's return that. Whoops. Run this code. You can see now the array of numbers is in ascending order. This is essential because this is going to help me with my frequency counting. So from here, I need to make a variable to store the frequency of the current item I'm on. So I'm going to say let frequency equal 1. Okay? Because the current item I'm on is going to be this 2. I'm actually right here on the index, but because I'm going to compare the current value with the previous value, we can say that the frequency of this 2 right here is 1. So if I say if array at index I, which is the current item I'm on, which is this 2, does not, or if it does equal array at index I minus 1, then we know we can increment our frequency, just like that. If this isn't the case, let's say that this was a 1. So I'm going to now do something else because these are not equal. So when I start my for loop, I'm going to compare 1 to 2 and say, hey, these aren't equal. So I need an else clause, and I'm going to say, if this isn't the case, frequency is just going to equal 1. Okay? That's all I have to do there. And now, after every time I increment my frequency, let me actually change this back to a 2, but every time I increment my frequency, I need to check, does it suffice this test case that I've written up here in this variable test? So I'm going to say if frequency of the current item I'm on equals test, return the current item I'm on, which we know is nums at index I. Just like that. So if I run this code, oh, well, it's actually nums. It should be nums. Sorry, I'm used to thinking in arrays, but the name of this array is nums. So let's run this again, and we get 2. So that works. This solution is nice because, again, I'm not using that map object, which is very memory intensive. Notice I'm still having a time complexity of O of n because I must loop through all the data, and then also I am sorting up here, which is an O of n time complexity event, but I'm not creating any additional relevant space. Yes, I am creating these auxiliary variables to store, the frequency, but that's really not that space intensive as an actual map object. Okay, so this is just auxiliary space. That's not that big of a deal. All right, let's test this in Leetcode and see what happens. Go back to Leetcode here. I'm just going to paste it in. See if it likes it. Looks like if nums equals 1, they're expecting a 1, but we are returning undefined. Okay. You know what we can actually do here is just return nums, right? So if I go back here, return nums at 0. So basically, if this never gets tripped up, if we never have something to compare against, we can just return nums. So let's try this now. Submissions, I'm just going to paste this code in again. Okay. Submit, see if it likes it now. All right, sweet. So how fast was that? It was a little bit faster time complexity wise than our other one. I don't know if it says we used more memory than our last solution. Yeah, I guess we did. But that's not based on, about the same. Actually, we used just about the same, but that's not entirely true because we didn't create that map object. This might be more exaggerated if the tests were to put in a larger amount of items. Like this should actually take a lot less memory because we're not creating that map object. Okay. Yes, we are storing some items in the test variable, but it's not anything like that map object. So this is the solution that they're asking for, where we're using O of 1 space complexity. Now I'm going to show you a solution that is like a show-off solution that will make you think like, wow, this was actually way easier than I thought. If I just would have read this constraint statement better, I probably could have thought of this. Okay, let's jump into that solution. Recall from our problem statement that the majority element will always appear greater than n divided by 2 times, or half the length of the array. So that means that the majority element will be greater than half the length of the array in its frequency. If that's the case, couldn't we just sort the array and just grab the middle element as that would be the majority element? Yes, we could do that. That actually makes a lot of sense. So let's first sort the array. So I'm going to come in here and just say nums.sort, pass in A and B just like before, use the arrow function, A minus B, just like that. That's going to make our array of numbers in ascending order. And then we can just return that middle value, right? Which in this case would be 2 because this is going to be a sorted array. And 2 has a frequency of 4, which I just said is greater than n divided by 2 times the length of the array. In this case, the length of the array is 7, and 2 occurs 1, 2, 3, 4 times. So I can just return that middle value, which should be 2. So I'll say return nums at index math.floor, because we want to floor half the value of nums.length, and then we do divided by 2, and this should give us our answer. So let's run this code and see what happens. Look at that. It works, and it's not that bad time complexity wise. Okay, so that is a perfect illustration of sometimes it's easier to work smarter than harder. If we would have just looked at this problem statement and really thought about it for a second, we might have come to this solution, which is 2 lines of code and pretty explanatory, honestly. So I hope you guys enjoyed this video and found it valuable. If you did, please like and subscribe, and I will see you in the next one.